All right, guys, let's look at it. So what are your 2 points that we start with on the board?
1, 0, and 5, 1.
Good. 1, 0, 2, 3, 4, 5, 1. Okay. And then of the transformations, which one do I have to do first? -2. And what is that -2 doing? Yes. Okay. So we're doing this guy first. So 0 times -2, it doesn't go anywhere. And then 5, 1, that'll become 5, -2. We're okay to that one?
Yeah.
Okay. What about my shifting now? Where am I going?
Up 3.
Okay. So I'm just counting the purple dots. I'm going to go 1, 2, 3, up 2. 1, 2, 3, up 2. All right, and where's my vertical asymptote?
-2.
Good. So it kind of looks like that. How'd we do, guys? Good. Sydney's like, I don't know. I can't see it. This happened in multiple classes for New York. Kids are like, I forgot my contacts, glasses, anything. It's hard. All right, we're okay with graphing? We're moving on, guys. We'll go kind of quickly so that those that have to leave early will get through all the notes before they have to go. And I checked portion, it's 11:30 is what the list says. 11:30. Cheerleaders, football is 11:40. Yeah, you guys are 11:30. Maybe drumline's 11:30 also. Drumline is the only one that has no time listed, so. All right, guys, exponents. So we're going to talk about all the separate rules first, and then we'll do practice problems where we combine a bunch of those different rules, okay? Guys, I need phones away. Like, away, away. Thank you. All right, first one is the product property. I have x cubed times x to the 4th. What do I have? X to the 7th. I think most of you know just add exponents. If you ever forget, you can write this out. X cubed is x times x times x. X to the 4th. 1, 2, 3, 4. Do you see how that's 7 of them? X to the 7th. Okay. All right, let's do power of a power. How about x cubed to the 4th? Exponent raised to another exponent? Yep, that is power of a power. That is x to the 12th. Again, you could write this all out. I will do it. You don't need to. It's a lot of x's. This is really saying 4 groups of x cubed, right? Do you see how that's 12? Okay. Again, tedious, but if you are desperate, there you go. Write it all out. Our next one, let's do quotient rule or quotient property. How about x to the 5th times y to the 4th over x cubed times y to the 9th.
X to the 6th times y.
You were getting it there. All right, when we're dividing, what are we actually doing with our exponents? Subtracting. Okay, so know that you're subtracting, but also ask yourself, okay, where are they going to end up? So if I look at the x's, how many x's will be left? 2, and where will they be? Okay, so x squared on the top. How many y's are going to be left? 5, good, but where are they? Okay. Now, again, this is the last one I'll write out this way, but you can always go, okay, x to the 5th, 3, 4, 5, 1, 2, 3, 4. 6, 7, 8, 9. You can cancel them out and see, okay, x squared left up top. Y to the 5th left in the denominator, okay? That's what you're doing. You can just do that in your head usually. Questions on the quotient property? You guys are remembering most of this? Yes, okay, good. Good when it's a review. Let's talk about negative exponents. Let's say I have x to the negative 3rd over y squared. If I want you to write that without any negative exponents, what has to happen? Yeah, x moves to the bottom is what's on top. Okay. That's it. All right. What?
Why do you pick it? Oh, never mind.
You see it? Okay. Let's do one more with the negatives here. Let's do a cubed over b squared, all raised to the negative 2nd. Close. You're very close. So this is combining your power to a power and a negative exponent. If you just see it and can write the answer, I'm completely fine with that. If you want to do it in 2 steps, that's fine as well. Power to a power rule would say this is a to the what? -6 over b to the -4. So what does my answer end up in the end? Yes. Gotta move the ones with the negative exponents, okay? You were just squaring your Okay. Talk about 0 power. What is 3 to the 0? 1. Do you guys understand why that works? Or are you just like, no, they said it was 1, always 1, 1. Okay, let me show you why. Let's say I have 3 divided by 3. Do you agree that that is 1? Okay. I'm going to write that as 3 to the 1st over 3 to the 1st. That's the same thing, right? If I use my quotient rule, that'd be 3 to the 1 minus 1, right? Subtract exponents when you're dividing. So that's why it's 1. Okay? Renata's like, what? Hold on.
Oh,
isn't that the same as 3 over 3?
yeah.
which is 1, right? Okay. So it's not just like a made-up thing that we were like, oh, put a 0 up there, it's 1, okay? It's not, there's actually a reason behind it. If you're like, oh, that makes my head hurt, I'm just going to remember that it's 1. Great, that's okay too. Okay. All right, rational exponents. Last little rule here. If I have x to the 3/4, what does that actually mean? Not quite. The 4th root of x3. 3. Yeah.
The 3 is somewhere.
The 3 is living somewhere. You can write it that way, or you could also do the 4th root of x cubed. Those mean the same thing. So just remember, when it's a fraction exponent like that, the denominator is telling you the root. The numerator is just your normal power. Let's do one more to make sure you've got it. Let's say it's a to the 5/7. What is that really saying, Ricky? Yeah, 7th root of a to the 5th. And again, you could do that if you like that better. Okay? All right, we're ready to now put things together. Usually you guys are really good at the rules when they're like, this is this rule, this is this rule. But when I give you a problem that has lots of them together, that's when it gets trickier. Okay, so we'll practice everything together. You good, Julian? Almost? Yeah. Okay. All right, let's practice. First one here. C to the 5th, D to the 3rd, over C cubed, D squared, all raised to the -2nd, times C cubed, D to the 4th, over C to the -2nd, D to the 5th, all cubed. I told you we were going to put a bunch together. I did not lie to you.
It's a lie, but it's not actually that one.
Right. It's just like C, D, C, D, C, D, C. And poor Sydney's like, I don't know what any of that says. Maybe you can you see, like, can you jot it down from Kara's paper? Or, okay, oh, okay, awesome. Try this one, guys. It's going to take you a minute. That's okay. Yeah, once you write it, double check. Look and go, did I write it correctly? Because, you know, that can be a problem. Work with your neighbor, it's okay. That's fine. Put it away. All right, guys, let's go through it. Walking around, lots of you got there. Leave early.
We gotta get
Prime seats for the pep rally. All right, guys, there's a couple of ways you can do this. I like to simplify inside the parentheses first, just because it kind of makes things smaller rather than gigantic numbers to begin with. So then this is going to be 1 over c to the 4th d squared. Are we okay with that for that first parenthesis? And then this one is c to the 15th over d cubed. How is what possible? Sure?
Wait, is this only one? I just messed up.
Where? Which one are you talking about? This?
Yeah.
Like, how did I go from here to here?
No, wait.
I reduced in here first.
Oh, wait, we're solving. I thought you were already going to do it.
Oh, no. I'm just going through this one. I'm like,
what?
right, what's happening? Okay, then if I'm looking for what's left, where is it? I have c to the 11th in the numerator. And d to the 5th, I can combine those in the denominator. New problems coming, don't
I
worry.
was like,
Anybody questions on that one? Okay. I'll start writing the next one while you're catching up on that one, okay? The next one's a little more difficult. I'd call that one like medium difficulty.
Give us one that takes like half an hour.
None of them should take that long.
you just give us unsolved problems.
Just, I could just keep writing new fraction, new fraction, new fraction.
Accidentally solving all your Stokes from high school.
I could just keep writing fractions and just never stop writing. I'll move it up here in a second. You okay, Julian? Okay. Thank you. In the second parenthesis there, that's a 6a squared b. Make sure my 6's and b's don't look alike. Yeah. Yes. So that's 6 to the negative 1. Okay? Guys, that's not negative 6. Does everyone understand that?
Isn't it just
1/6, yes. Yeah, there's coefficients this time, guys. You've got to deal with those coefficients. I said this one was a little more difficult. I did not lie to you.
I didn't say that.
None of us ever accused you of lying.
One step at a time, guys. You'll get there. What do you mean? This is part of pre-calc. Gotta be able to work with exponents. What am I gonna do with it? So we're gonna get to lots of things that if you don't understand how exponents work, it's just not gonna go where. Like, we're gonna solve different equations with exponents. Later we'll get into, I guess you guys won't do the derivatives yet, but when you get into calculus, if your exponent game is weak, calculus is not real fun. Do you have a 4 over 81?
You over 162 and I was like, that can't be right.
Reduce, you're there. Renata is saying good things back there. What is what? What does a negative exponent do?
What's 1 6 and 5?
What do we do with negative exponent? Well, now, like x to the negative third. What did that do? Okay.
For a squared, the negative third, if you were to do that, it just means that
I'd simplify in the parentheses first. Like simplify the a's first. 30 more seconds, guys, then I'm going through it. No pressure.
I just feel like that's a little bit of
A little bit, yeah.
yeah.
Got it? Do you have a 4 and an 81 somewhere in your answer? It's a good sign. Yeah.
That was the part I was really worried about.
I know, the coefficients, which is funny, you should be like, they're just numbers, but somehow that's harder now that we're doing the variables.
Everything else is adding subtracting.
That's true.
I think it's like I did it like one.
It's true. You in, James?
I'm looking at Moss people. Moss has no idea what it is.
And he left.
I think he thought that 8 divided by 27 was 3 over 1.
Oh, yeah, it's not.
Yeah.
Yeah.
So I'm trying to look at history to see what happened.
You should look at Anna's, not. Yeah, that's a better choice. You might need a new shoulder partner. All right, guys, let me go through it. So I like to simplify inside the parentheses first. Is there anything to simplify on that first parenthesis?
No.
No, so I'm going to cube everything that's in there. What is 2 cubed? 8. A to the third. What will that become? No. 9. Power to a power. We multiply. B to the third. Over. Okay, 3 cubed. 27. C to the... Okay. Are we good with the first parenthesis? All right. Second one, I am simplifying inside that parenthesis first. The only thing I have to deal with is the a's. What do I need to do with that a to the negative fourth?
Stuff.
Yeah, stuff. Move it to the top. And then I've got a squared and a to the fourth. So what does that really become? Okay. So I now have 6 a to the 6th b over c cubed all to the negative 1. Hold on. All right, I'm going to just rewrite this first parenthesis. The second parenthesis, guys, that entire thing is raised to the negative 1. What does that mean? It just flips, right? Don't do each individual term. Don't go, okay, let me write 6 to the negative 1. And now I'm moving the 6. You know everything is flipping, okay? So I've got c cubed up here. 6, a to the 6th, b in the denominator. All we have to do is simplify from there. I don't want to multiply 6 and 27, so let's reduce coefficients first. What could I reduce by?
Yeah.
2. Yeah, the 8 can become a 4, and the 6 can become 3. Make it smaller, not bigger, guys. All right, so all I have is a 4 in the numerator. What's my coefficient in the denominator? 81. 27 times 3 is 81. Okay, then I look at the A's. Find all your A's. How many are left and where are they? Okay. Look at the B's. How many B's are left and where are they? Okay. And C's. Okay. There is your answer. How'd we do? Close? Okay, does it make sense now?
Yeah, I just, instead of cubing the 2, I multiply.
Yep. It happens. All right, let's try. We got a few more to get through. Because I reduced 8 over 6 to 4 over 3. There's an 8 in the numerator and a 6 in the denominator, so I reduced that. I know, it is 11:30, so unfortunately, yep, you can go. Homework's on Delta Math. So if I have 3 times 2 over 4 times 15. Hold on. 8 and 3 don't reduce.
But you can make the 6 and 3 without doing anything else.
Well, look at just reducing numbers here, right? I can turn that into a 5.
Why is the 3 of the 20 again?
I just forgot.
Okay, we have to keep moving, but it's just reducing fractions. I had 8 divided by 6. These were your coefficients, right?
I thought we would.
We're multiplying. That's all we're doing is multiplying and dividing.
Multiply the denominator.
You're simplifying. If you really need to multiply it out first, you can, but all you're doing is making more work for yourself. Because I don't want to do 27 times 6 and then try to reduce 8 over 27 times 6. But you have to be okay with understanding how reducing works. So, I mean, we're talking basic fractions here. What is that? That's what we did in the problem. Okay. All right. Try another one. No, this one's shorter. I told you that one was harder.
That was That's why I get these guys.
So an exponent that's a fraction. Okay, let me move it up a little. And Harper, can I have you need like half an hour for the assessment, so I'll have you go start those now. Yeah, they're short. Probably today. You guys should have time to get them back by 3rd and 7th. So.
No, it's too good.
All right, guys, what is this? X to the 3/5. We okay with that? Okay. Let's try again. Evaluate. 8 to the 2/3.
thought as much as possible.
Yes.
Let's keep times it. What are you talking about?
There's two ways you can do this one, but you get the same answer either way.
Oh, so you want to just like.
No. This.
Like, what is the simplified answer? So at 11:30 was madrigals. Are you in a group? 11:40. So you got 6 minutes, okay. Okay, guys, what does 8 to the 2/3 mean?
4.
Yes, it does mean 4. Yeah, it means the cubed root of 8 squared. I would rather do this, the cubed root of 8, and then square it, so that I don't have such big numbers. You can do the other way too. It's not that bad this time. Right? Yeah. Because what's the cubed root of 8? 2. What's 2 squared? Okay. You can, of course, do this cubed root of 64. 4. Either way, whatever works. But think about that way if it's like large numbers, okay? So you're okay with like this setup? Okay. What is the cubed root of 8? What number times itself 3 times is 8? What's 2 times 2? Times 2? Okay, so the cubed root of 8 is 2, okay? So this is 2, and then I square it. That's where the 4 comes from. Okay? All right. Let's do maybe 1 or 2 more. What do I want to give you? Let's do one more simplify, okay? Last one. That was a 5, yeah. Try that. Yes, I'm just making that up for you as we go, so enjoy. Start on the inside, one step at a time. You can do it. Trouble setting. I haven't done it yet.
See, look.
Okay, so let's do
We didn't know this. What did you get? Because you took the one was fine.
It's tricky going back to
Four squared. It's right. I've done this right. It's even different. It's something right now. I'll say
You got it. Oh, you get there.
no. That's the first
I don't think he
Making
got.
up weird numbers.
I don't think he got there.
Which is right.
I haven't done it, so.
My I don't think
Doesn't make any sense.
it's not looking great. Because it was 9 times 4. Instead of like a 1.
Where did you get 9 times 4?
Because it was 1 9.
What are you telling
It was
me?
1 9 times 10.
Who are you?
All of this stuff is like
Yeah.
9, yes, 4, yes.
Times 4 and then 4. Oh, but it was 1 9, so it's in there.
You're right, if you have 9 in the denominator. 4.
That's
So hey, look, I like feel like I just put it in your head. It's like it's floating
It's 4.
inside.
It's 4 over 9. It's 4 over 9.
it's good to not know what.
So it's, I got that right here. Though. So I got there.
Well, I don't know that. I just put that there.
Like the end wasn't right.
We'll go through it. Okay, guys, let's go through
Then
this
it's
one.
64.
We're getting some interesting answers. Let's see if anybody got it. All right. Again, I'm going to simplify in the parentheses first. There's not a ton to do in the first one here, but I'm still going to rewrite it. Did we get a to the 7th in that denominator? Yes, okay with that. Okay, and the other one is going to be 4a to the 5th b cubed squared. Step 1, just inside the parentheses. Oh. Okay. Guys, the first one is to the negative 2nd power. What is the negative going to do to everything in that parentheses? Yeah, so I'm going to square it because it's the 2, but then I'm just going to write it. If it was in the numerator, it goes in the denominator, vice versa. So I'm going to get 4a to the 14th in the numerator and 9b to the 6th in the denominator. Okay? Yeah, okay. All right. This, there's no fraction, there's no negatives, you are just squaring it. So I have 16, a to the 10th, b to the 6th. You can put it over 1 if that makes you feel better. Okay. 4 times 16 and then over 9. Yeah, nothing reduces there. So it's just 64 over 9, right?
It's almost just better, right?
A's. What am I going to have for A's? 24 up top? Yeah, okay. Yeah. Anything else left? So that's what happens when I make up problems. They get weird. That's it. How many got it?
We got it.
Okay.
I got it after you wrote it.
I got it before she took it.
Got it. Yes, yes, I like it. All right, guys. Let's stop there for so many reasons.